So let us begin with logistic regression. So this is a supervised learning wherein we have a target column, and the target column is a categorical type, data type. So if we want to look at the what do you call our training test and training data and the test data, I just want to show you how the data set looks like, and then we can proceed with the pre-processing steps. So this is the one of the data set from the Kaggle again. This is around prediction of Australian weather based on some features. So this is the training data set wherein you have the location from where the record was picked up, and on a given day what was the minimum temperature and maximum temperature, and what was the direction of wind, at what speed the wind was going, and what was the humidity, what is the pressure, and the cloud, the density of cloud and sky, and the temperature and all. Okay, and whether it rained today or not. So based on this, we have to go and classify whether it is going to rain tomorrow or not. So the target column has only two different values. So let me just go and show you the distinct columns. So we just have 0 and 1. Okay, so we have to classify the data into zeros and ones. So this is the complete data set. So we have a lot of null values, as you can see, and we would be trying to use logistic regression for making this classification done. So let us go back to Python now. I'm going to load the same data set into pandas memory, and then we will try to complete the pre-processing stage. For the coding purpose, we'll be using many different libraries. Say, for example, we'll be using pandas for our loading the CSV files in memory, Seaborn and matplotlib for the visualization purpose. Then we have sklearn. In sklearn, we have something called as pipeline, followed by column transformer, followed by some one-hot encoder and standard scalar. This for pre-processing step. And then we have for the model purpose, we have the linear model, logistic regression, followed by the metrics. Whichever we want to analyze how well the model is performing, that we'll be using. For that, we'll be using metrics. Okay, let us begin. So this will be our first step of inputting all the libraries. So you can find this code in our Git. This is the GitHub, and also the dataset from Kaggle, just in case if you want to download. The dataset is also available in Git, but if you want to see uh, how the dataset looks like, with the description and all, then you can definitely go and see in Kaggle. So this is the Kaggle dataset. Okay, these are all the different features and the description. We don't need any other information from here. Just in case if you want to look at it, you can have a view. So first thing what I'll be doing is, previously in linear regression, we talked about only one data set wherein we did a split on train and validation. Okay, but this time what we'll be doing is we'll also look at the test data set, because we want to make use of the model on the unseen data, not on the data which is already given to us, right? So this test data set is an unseen data which is not passed to the model. We want to make use of this and make the predictions on this particular data set. So whatever uh, pre-processing steps that we will be doing on the train, the same pre-processing steps we'll be doing on test simultaneously, so that you get a feel about end-to-end cycle on applying the machine learning model. Okay, so I have loaded the data frames. You can just have a look at how the data set looks like. We do one thing. Let me clear all the outputs. So I have loaded the data frames. This is how the data set looks like. Okay, and we have a target column, rain tomorrow. It is a classification problem. Okay, we just have zeros and ones. It is not a continuous feature, just like in linear regression. Here it is a classification data type. Similarly, in the test data, you do not have the target column. See, we do not have rain tomorrow. Okay, we can also go and see describe all, which will tell us what are the different values that we have. If there are any uniques, it'll show you the uniques. In some cases, probably we do not have uniques. Say, for example, if it is continuous data, then you do not see any uniques. And then you see a range. What is my minimum? What is my mean? What is my median? What is the minimum value? And what is the maximum value? Okay. We can also go and see for rain tomorrow. This is our target column. What is the value underscore counts? So it will tell you for class 0 we have about 77%, and for class 1 we have about 23%, 23% odd. Okay, so the data set is not uniform. Okay, we have more number of records for class 0 and less number of records for class 1. This is called as a highly imbalanced data set. Generally, this is still far better. Generally, when you deal with real world problems, right? You might notice something like 90 and 10 or 95 and 5. So you will have to apply more techniques to take more samples from the class 1 rather than class 0. That we'll talk about it when we go to the higher models. Okay. For now, let us not look at imbalance. There is some imbalance. The model is going to look at class 0 more, but let us see how we can resolve this. Okay. These are the shapes. For training purpose, we have like close to 1 lakh records, and for testing purpose, we have like 42,000 records. We will begin with pre-processing steps. Before pre-processing, I just wanted to show you the data set one more time. Uh, so looking at this data, right, what I felt was if I pick one column at a time, uh, I will have to make use of this particular column, something called as rain today. Okay, so if there was rain today, all the other parameters are gonna change. Say for example, if you're sitting in Hyderabad and if there is a rain today, obviously the temperatures are going to go down, the humidity is going to go up. Okay, and so simultaneously your evaporation rate also goes down. Okay, so what I felt is the first column that we should handle is rain today. So I'll be looking at rain today. When I look at rain today, let us say, so when I look at rain today, I have no as 76,000 records and yes as 22,000 records. And there are close to 1,000 records which are null. So what I'll do is all these null values, I'll replace it with no, because it is a mode. So obviously, like because there are null values here, I'm going to replace them with no. And it is a simple impute, right? I'm going to use fill in a dot fill in a 0. Okay. Now I don't have any null records in rain today. The second thing which I also noticed in the data set was if you look at the first column, row ID, row ID has row 0, row 1, row 2, and so on. We don't need this because this column is completely just an identification, and the same pattern repeats in test data set also. So the row 0 here and row 0 here has no relation to them. So what I would be doing is I will be dropping these columns. Okay, I can, for dropping those columns, I can just simply go and what is that? Yeah, I can just drop a row ID in both the data sets, row ID and row ID in data and row ID in test. Now let us go and see what is our null values in other columns. Now you see that there are other null values, right? In evaporation we have close to 42%. In sunshine we have close to 47%. This is a percentage. Okay, I'm just dividing it by the shape of the data frame, and most of the values are present in cloud 9 a.m., cloud 3 p.m., and evaporation and sunshine. We'll take one at a time and then see how we can resolve this. This is a view of test. Okay, rain tomorrow we already discussed. So let us first take about minimum temperature. Okay, minimum temperature looks like this. It has couple of outliers, but the mean and the median are almost similar to each other. It's at the center of the box. I think the same can be evident by using dot describe, where you can see the median is around 12 and the mean is around 12.1. Okay, so what we can do is like wherever we have null values here, the obvious guess is that I can go and replace with mean, correct? But I don't want to do that. Why I don't want to do that is, say Australia is a very big region, right? And just like in India, the temperatures in say in Jammu Kashmir and the temperatures in Kerala are quite different. And if there are null values in Jammu Kashmir and null values in Kerala, I should be trying to find some value which is closer to Jammu Kashmir and put it in Jammu Kashmir, and find a value which is closer to Kerala and put it in Kerala. Not like the whole country. I'll take the whole population of India and then from that population I'll take a median. That would be wrong. So what I would do is I will calculate the median at location level. So in order to do that, what I'll do, I'll take location. I'll do a group by on location. I'll also consider whether it rained or it did not rain in that particular location, and then find out the median. Okay, if my assumption is correct, then I should see different medians for each location, right? So if I look at Adelaide, when there is no rain, the temperature is 12.7. For same Adelaide, when there is rain, the temperature is 10.8. So there is a difference in median, right? Again, if I compare Adelaide to a place like Wollongong, here the temperature is 14.5, and when it rained, in fact, the temperature is higher, 15.5. This could be just by chance, but that is what the dataset says. So if I go and find out the median for complete Australia, let us say if I go and find out the median for Australia, uh, data, if I minimum temperature dot median, it's 12, all right? But this 12 as compared to each location might be different, right? There might be a deviation for, if you notice Whitcliffe, it is lesser. If you notice Woomera, it is higher, and so on. So what I'll do is instead of taking the median of complete Australia, we would be taking median of each location based on whether it rained on that particular day or not. Okay, this is what we got. Now what we'll do is wherever we have null values, let us say if we have null values in Adelaide, we will look at rain today column. If the rain today is no, then I'll put the value as 12.7. If the rain today is yes, then I'll put the value as 10.8. As simple as that. So in order to do that, we will make use of transform. Okay. So I'm going to create one more column. Let us say, I just want to show you what this code does. Did you notice what has happened in the group by? In group by, when we did a group by on location and rain today, it has combined all unique possibilities or unique combinations, and it has given a data frame outside. So this data frame has got only 98 records. But on the other hand, if you use transform, like in this case, I'm going to copy it to another cell. If I'm going to use transform, this we are going to get the size of data frame, 99,516. So whenever you don't need to change the number of rows, you can use a transform. But transform will not work in all the cases, just like how we can get a data frame, right? Some cases it is good to get a data frame rather than doing a transform. But in this case, I want to create a column which can track median of that particular location, given it rained or it did not rain, and then track the median. So for that, I'm going to catch the medians like this. I'm going to transform and getting the medians. Okay, I'm storing it in one new column called location minimum. In this location minimum, I'm going to replace all the null values that is present in minimum temperature. This is a dot log. I think we already remember. We discussed this in Panda's class. This dot log is we are going to use in minimum temperature and replace all the values from location minimum. For the same subset, wherever the minimum temperature is null, I'm going to take the value from location minimum, copy it to minimum temperature. So location minimum will not have any null values. So just in case if you want to see it, print data location underscore minimum dot is null dot some, and I just want to add some print saying it came from, so null values in log minimum. So when I execute this code, I don't get any null values here. So what I'll do is from this column, I'm going to copy the median to all the places where the minimum temperature is having null. Okay, and then I'm going to drop this column whichever it's not required, because it's a temporary column I created. I'm going to drop it. Uh, Before dropping, what I did was I created one temporary data frame which took only the unique values of location, rain today, and location minimum. This data frame, what you see, tempdf, is nothing but the same data frame that we saw here. This will have about 98 records. What I'm going to do with this is I'm going to use this data frame to replace all the null values in my test data set. I'm going to do a left join. Wherever the minimum temperature is null, I'm going to use location minimum, copy the values from location minimum to minimum temperature, and then I'll drop the minimum location minimum column here also. Always keep this in mind. This is very important. Okay, whenever we have more data sets, we will be looking at we'll be looking at one of the we'll be looking at one of the data frame, which is our train. Okay, this train will divide it into randomly. We'll pick records and we'll divide it into 80 and 20. Let us say that this is 20%. Okay, and this is like 80%. And then we will have a test data set. This is our test. Any imputation that you do on train, you will calculate the 80% values, replace the values here. The same values will put it here also. The same values will put it here also. Any calculation that is supposed to be done should be done on the train data set, not on the validation data set, not on the test data set. In other words, when you do a fit underscore transform should happen on train, transform should happen on validation, transform should happen on test. The same thing what you're doing. I did for the complete train data set, I took a median. That median I applied on train again, and then I applied on test. But on test, I'm not calculating the median again. That is a wrong way. Always keep that in mind. Not just median, any value. If you're making any calculation, that calculation should happen based on your train data set. Okay. Having said that, now I'm going to look at what are the minimum temperature null values in both the data sets. I don't find any null values in train as well as test. Similarly, for max temperature, it's the same activity. Okay. Max temperature also is the same code, just the column name is changed. Okay. Now what we'll do is we'll try to look at rainfall. Okay. This is the third column that we are going to take. Now rainfall is one of the column which measures how much rain it actually happened. Say for example, I took random 20 samples from this data set. Okay, if I do this code one more time, it will take another 20 samples. Look at what happens when the value is no. When the value is no, the rainfall is 0.2. When the value is no, the rainfall is 0.8. No, 0.0. No, 0.0. No, 0.0. It means that when there is no rain, the rainfall is almost close to zero. But and in an event when there is rainfall, as yes, the value is way higher than zero. Here it is 5.2, here it is 2.0, 3.4, 20.0. So what we should be doing, whenever there is a null value that is present in rainfall, if for that particular record rain today is no, I'm going to put it as zero. On the contrary, for a record where the rainfall is null, and in the same record, if the rain today is yes, then I have to find one value which is greater than zero. Okay, there are two tasks. First task is put zero where it is no. So what I'll do is, you can notice this particular lines. What I'll do is I'll simply subset my data. Wherever it is no, I want to fill the records as 0. So let me just try to show you in one simple example. Here I'm subsetting. What I'm doing is, so instead of putting just rainfall, let me also take, okay. So when I'm doing a subset, you saw that I'm going to get rainfall. These are all null values because my condition is that I want rainfall to be null and rain today to be no. I'm getting all those records. Now what I'm going to do is I'm going to simply replace this with zeros. Rain today, this rainfall. Okay, I'm going to put 0. And then I'm going to do the subset one more time just to show you what happens here. Okay. Again, I'm taking rainfall, rain today. Oh, this is not null, right? So we don't have any null values here. That's why you don't get the subset. But I'm going to show you zeros because if we have already replaced with zeros, you'll get zeros. So wherever you have rain as no, all the records have zeros. But we have done it only for those records where it is null. Okay, the actual values we do not replace. The same thing I'm going to do it with yes now. So in order to do with yes, I did not go at a location level. On an average, I took what is the median for the complete Australia. Maybe you can do it also at location level and see. That is also possible. You can do it at location level. So what I'll do is I'll simply calculate the median for the complete Australia, given a case where it rained. Okay, and I took only those records where my rainfall is greater than 0. So it is saying it is close to 5.2. Okay, so what I'll do is I'll simply go and replace those values. Now this is how the distribution looks like for each location. There are a lot of outliers and most of the values are close to 0. That is why you don't see any boxes here. Actually, it's a uh, box plot visual, and all of them are outliers. Okay, so for now what I'll be doing is I'll be taking 5.2 as my uh, go value and then I'll replace it and doing it for both my test and train because it is a static value. Notice that the median is coming from data, not from test. Okay, the same median I'm going to put it in my train as well as my test. Always keep in mind any calculation that you do, calculate using the train data set, apply it both on train as well as validation and test data set. Now, just as we did, I took rainfall. I don't have any null values here. The next column, what we're going to do is a similar approach. Whatever we did just now is a similar approach, but we'll try to do it at location level. I will take evaporation. Okay. Now, looking at the data set, what I felt was whenever there is a rain, the rate of evaporation will be less. Why? Because there is no sunshine, right? So I just wanted to check if my intuition is correct or not. So what I did, I took one location, say sale randomly. You can take any location that you want. I took sale as a location. I did a group by on location and rain today and found out what is the mean and median of evaporation. I noticed that when there is rain, the median is slightly lesser, and when there is no rain, the median is slightly higher. It is expected, right? Of course, when there is sunlight, then there is a higher amount of evaporation taking place. Similarly, if I take a different location like Canberra, now here also you notice that the medians are slightly different than that of Sale. So our intuition was correct. Based on the location, the evaporation might change. Okay, so if we are supposed to replace the null values that is present in evaporation, I definitely have to look at the location first. And then I have to look at whether it rained or it did not rain. Okay. Okay. Then one thing, before I proceed further, just notice what I'm going to say. Okay, let me annotate. Now, let us say that we have location here, and then rain today, and then okay, this is one location. Let us say there is one location A, and this is one evaporation. Okay, rain today for the location A, there was no rain here. Evaporation was 0.2, and then we have our same location. Rain today, no, 0.4. Like this, we have so many records. And then I have one record A, no. Here we have a null value. What I'm going to do is, first I'm going to group by on A and no, find a median of this. Let us say I got a median as 0.3. When I get the 0.3, I'm going to replace for just A and no as 0.3. Okay. How I'll do that? It's the same thing. We can do a left join and just wherever the location evaporation is null, impute from temporary column, which is having the median. This is okay. What if all of these are null? Let us say we have one more data set. I'll clear it. Again, we have location, rain today, evaporation. I take a different location now. B, it rained, but here you have a null value. B, it rained, but again you have a null value. When I do a group by on this kind of a location, because all the values are null, I'm going to get median as null. Okay. So in order to avoid this problem of getting one more null in my median column, what I'll do is I'll try to do a group by on without considering the location level. I'm just going to consider at rain today column, find out what is the median for uh, those records where it rained and apply it here. First, I'll do at location level. If I'm going to get at location level, then fine. If I'm not going to location at level, then I'm going to do at country level. Just keep that in mind. I'm going to show you how it happens in the code level. Now I'll take rain today operation. When I see, I created by using transform, I created one column temp evo, but I noticed that in temp evaporation, I got like 30,000 records, which are null. Okay. So in order to replace these nulls, I'm going to do one more group by without considering the location. Here I did a group by on location. Here I'm going to consider without location. And when I do this, you notice that in my second temporary column, I don't have any null values. Because there are no null values in rain today, I'm not going to get any null values here. Okay, now what I'll do, whichever column that I created in temp evolve, first I'm going to replace those null values by the median of the country level. It is not at a location level, it is a country level. Then once I do this, when I find out the null values in temp evo, I don't get anything. Okay, it is simple, like if you have null values in location level, look at the country level. At the country level, there are no null values. Impute that into temporary location. Now you have created here. From here, again, you're going to impute into actual evaporation column by doing the same subset. So from temp evo, we're going to get it into evaporation. Now in evaporation, I don't have any null values. Using this column, again, I'm going to create one temporary data frame, just like earlier how we did. I'm going to capture all the distinct values of location, the rain today, and temp evolve, temp evaporation. And I'm going to use it on my test data set. I'll do a left join, and then I'll copy the values from temp evo to evaporation. It's the same activity. Then I created two columns in data, temp evo and temp evo 1, and one column in test temp evo. I'm going to drop them off. So far, so good. Now I'm going to look at what are the null values that is present in both my columns. So print data evaporation dot is null dot sum. I'm not getting any null values here. Similarly, for test data set, if I want to go and look at it, test, I'm not getting null values here. I'll pause my recording. Let us jump back into this call in few minutes, okay? I have exhausted the 40 minutes threshold. So let's connect back again.
Okay.